All right, we are back again with AP Bio walkthroughs. This is question 45 from Barrons practice test 1. And it is talking about something happening in the mitochondria. So let's take a closer look. The graph below shows the pH difference across the mitochondrial cristae membrane over time as a normal cell is respiring. The mitochondria right here behind me. What is happening across the membrane? What happens in the mitochondria? ATP synthase. I wonder if we're going to be asked about that. So the pH difference across the membrane. Okay, is that just the pH across the membrane? No, that's the difference, right, in pH across the wall. Okay, so over time, is it going to change the pH here or the pH here, right? Is it going to change at all? Okay, so that's what we're looking at. And so here's the pH difference. As it goes up, there's more difference across the membrane, okay, which means the pHs are more different from each other. And of course, there's time. All right. At time X, a metabolic poison is added to the system, which immediately and completely shuts down all functions of the mitochondrial ATP synthase molecule. Right? That's what you find in the mitochondria and across the membrane. Which of the following graphs correctly demonstrates how the rest of the line in the graph would appear? Okay, so before you even look at those and start choosing which one looks best by instinct, don't do that for one thing. Don't always use instinct, right? It's a nice combination of your logic plus instinct. Before you look down there, think about what is going to happen if you shut off the functions of the mitochondrial ATP synthase molecule. Your ATP is probably going to go down, your ATP production, right? But there's nothing on this graph that measures that, so that's not what we're thinking about. What runs the ATP synthase? There's a proton pump. There we go. So across the membrane, you've got your ATP synthase right here. Oh gosh, not a very good drawing of it, but that's okay. And then it's powered actually by a proton pump. Okay, so this proton pump lets protons come in. H, okay? And for each one that comes in, a certain turn, right? This turns a certain distance. Okay, so it's just like a hand crank, except it's being cranked by protons. Okay. So you've got all your protons here, and you've got your protons down here that have been pumped through. Okay, so the ATP synthase, the whole molecule here, depends on a certain gradient being maintained across the membrane, right? If there's too much of a difference, it's not going to turn at all, or it's going to turn so fast that it breaks, okay? Because your cells, they're just like tiny machines. They can be overwhelmed with things, all right? So let's see what exactly it's asking us here. So which of the following graphs correctly demonstrates how the rest of the line in the graph would appear if we shut down all functions of the mitochondrial ATP synthase? It's got something to do with H going across, right? Okay, so the more H's you have, H is acidic, right? So the more H's you have, you're going to have a lower pH. But is that what this is asking? Is it asking just your pH? No, it is asking the difference, right? So it's asking about how different is it going to be on one side of the membrane versus the other, okay? So if you got more H's on one side, then it's a lot more acidic than on the other side. So what do you guys think? Is the difference going to go up? Is it going to stay the same? Right? You broke the ATP synthase machine, which means you broke the proton pump, right? So a gradient can no longer be maintained. So it's probably not going to be A. Okay, so it's probably not going to be like that. The pH difference going down, you think it's going to get more equal across the membrane? Maybe over time, but it's definitely not going to like plummet like that. So I'm gonna X out C and A. What about B? pH difference across the membrane is gonna increase. I think so. Why? Because I think that over time, as you have this membrane, you've got your proton pump that is just blocked, okay? And you've got ATP synthase down here just waiting. Your protons, I think they're gonna build up out here. I think there's gonna be so many darn protons that it's gonna get kind of acidic out here, and you only have a couple. So I think over time, more and more protons are gonna be coming in, right? Because the mitochondrial membrane allows protons to come in so that a gradient can be maintained across this inner membrane. But so I'm liking B because I think that the difference is gonna go up after a while, okay? And D, let's go down here and look at D. pH difference across the membrane is going to just gradually go down. Now this one is also tempting too, if you think that, oh, well, what if this proton pump is just completely removed somehow and the membrane is just open? Well, that could be a possibility, but it doesn't say anything about that up here, okay? Because this would require, D would require a very particular thing happening, which is not only the proton pump breaking, but basically disintegrating, but then also your membrane becoming permeable for some reason, right? So this requires two things, your proton breaking and your membrane becoming permeable. We don't know if it's not true enough for us, right? So I'm gonna say no. And in fact, D is not the right answer, B is, okay? As protons accumulate, the pH value decreases, right? Becomes more acidic. The y-axis of the graph is pH difference across the membrane, so we're not looking at pH, okay, decreasing. That's another way that you could misread this bottom graph here, is by thinking that it was showing you just pH, right? You're like, oh yeah, the pH is gonna go down over time. That makes sense, but that's not what the axis is saying. Okay, so nope. All right, thank you. See you later. Hey guys, thanks for watching my video. Jen here. This is the third one I've uploaded and I'm gonna keep doing it, but I wanna hear from you guys to make sure I'm not wasting your time. Please put in the comments what you would like to hear from me. If it's a concept that you are just not getting, I'll find a walkthrough question on that concept. Okay, if it is a certain calculation that you're like, I know I'm supposed to know this, how do I do it? I'll find a walkthrough and I'll do it. I'll show you how. I'm also going to be having videos about how to manage your time on the test, because that's really important. You know, you don't want to be stuck there in a cycle of anxiety going, oh my gosh, time is just going by. So we'll learn how to manage your time, how not to freak out, and of course, how to tackle questions. What's a good strategy? Okay, so again, put in your comments. What do you want to know? All right, and don't forget to like, subscribe, all that nice stuff. All right, and I'll see you tomorrow.